Hello, welcome to the newest video I've posted. Obviously, currently this is my newest video, so if this is in the future, it won't be so new, but I'm back making some videos. It's been a minute. I had a kid, and let me tell you, having kids will really stop you from making YouTube videos, especially ones that take some time like this. Also on top of that, I am working on a podcast with my father-in-law. Has nothing to do with programming. If you want to check it out, it's called Generational Gap. I'll try to put a link in the video or in the descriptions. But today we are back making more Python videos. So I have a whole series of Python 3 videos, from setting up your Python on a Mac, which seems to be a really popular video. It's kind of my biggest video. Got some videos on digital logic, if statements, if else, elif statements. I've got a video on automation, got a bunch of videos on Python 3. And so in my mind, the next logical step would be to do a video on functions. So today, this video is going to cover the basics on how to work with functions in Python 3. More specifically, in this video, the learning objectives are going to be to define a general function. So what does a function mean in just math, everyday life? What is a function? I also want to define a function in Python 3. We're going to examine function structures. So what does the function require inside of Python 3? What is the syntax for a function in Python 3? And when to use a function. So I'll kind of chat a little bit about when I like to use functions. I'm going to take a look at the difference between functions and automation. So when to use functions and when to use loops. And then we'll finish the video off with just a couple different examples of functions that I've created in the past, and maybe trying to demonstrate a couple different reasons why, or a couple different uses for functions. I mean, functions are very dynamic, and they can be used for everything and anything you want. It's just a matter of knowing what you can and can't do with functions. So definitely got some good examples trying to highlight some of the key aspects of functions. So I think we're just going to move right on into it. So defining a function, in mathematics, a function is a unique relation between the values of a set of numbers. In terms of x and y, each x value defines a single y value. So we're going to see that in Python 3, when you add something to the function, when you call a function, you're going to get a specific output, okay? And whether you're inputting values in, that specific inputted value into that function is going to output something unique to the caller. So same thing in mathematics. If you've got, I believe I have a video. Yeah, so I have a little video of just a slope function. So here's a simple function in mathematics called a slope. This video is taken off of a TI calculator, and we've got y equals mx plus b. I probably should have written that down somewhere here on the side, but f1x, that's supposed to be y. And when you input different values of x's, which is right here, so they correspond to a different value of y, because these steps within the function are different depending on the inputted value of x. So y, when x is, let me see if I could pause it. So when x is -1, so when we put -1 here and it goes into this function, we do -1 times 12, which would be -12 plus +3, which would give us -9. And you can see that all changes as the x values change. So the output is this y value, and the input would be this x value. And that's basically all a function is in mathematics, is a relation of numbers. And in terms of x and y, you can see this corresponds to something on a graph. And I'm not a huge math person, but I remember in math they say that there's the function test, and I think it's if you draw a line through a function or through the graph, through this line, if if it doesn't intersect at 2 points, it's a function. I believe that's what it is, because then that's saying that one x input equals one y output. So one input equals one output. I don't know. I forget what it is if you have one input and two outputs, but that's a function in everyday. Furthermore, a function would just be a process in which some system takes. So we're going to see that a function is really a set of steps that the program is going to take. The same set of steps are going to be taken every time the program calls this function. Now, depending on the inputs that it gets, it might change, right? But so we can understand a function takes inputs. Oh, my computer's going to die. Hopefully you guys didn't see that. Well, now you saw it because I just talked about it. But a function is a set of instructions that, based on the input, will give you a unique output. Cool. So that is a general function, whether it's in the real world, it's just a process or set of steps in a system. And in mathematics, it is a relation of numbers. One unique input equals one unique output. So let's go ahead and define a function in Python 3. In Python 3, a function is a grouping of code that can be executed from any place in a program. Functions may contain inputs which result in unique outputs. So I've got this little useless example of ASCII values. So this would be the input, and that's going to be A. A corresponds to 65 in terms of its numerical value. The ASCII value of A is 65. 1 has the ASCII value of 49, and W has the ASCII value of 119. Now, this could be some sort of function where you pass in the letter, and the output would be the value, would be the unique ASCII value. But this last portion, functions may contain inputs which result in unique outputs. This is not always true, so we're going to take a look at that in some of the examples. You don't have to give a function an input for it to work in Python. So the real world definition, the mathematical definition of a function is just what I would say the closest thing to a function in Python 3 as, the creators of the language, saw fit. So they said, oh, okay, well, this kind of mimics what a function does in the real world or in math. So we'll just call this a function. So some things, are correct, but some things can be bent a little bit in Python or, from the creators of the language. So let's take a look at the actual function structure. In the function structure, we're going to take a look at three things: the structure, calling, and the scope, all within this example. So the first thing we're going to take a look at is just this structure. So really pay attention to just right here. I don't want to click because I don't want it to jump to the next slide, but where you've got the comment, this is my function, and then it says def function name, parentheses, colon, and then print inside of function. So really this first line right here after the comment, def function name, parentheses, colon, is what we're looking at. This is the syntax for creating a function. So you can see down here, I say, try this on your own. If you want, pause the video, write this down on your IDE and run it and get kind of an intuitive understanding of what I'm about to talk about, because that's how I learned. That's how I got into programming and understanding all this stuff, is not by listening to somebody or reading. I mean, obviously it gave me more context, but just blindly kind of running this code and seeing what the output is going to be is really going to give you a lot of intuitive understanding of what a function is. But to the structure and the syntax, we've got def, which is for define. So the computer comes down each line, it hits this print statement, it comes here and it sees def, and the computer says, oh, okay, so what comes after def is the function name. So the function name is kind of like a variable. It can be anything as long as it's not, a special Python word, right? So in, for, set, whatever those, built-in Python function, keywords are. So define, function name, and then the parentheses, which are, I believe I don't know what they're called, but they're the parentheses. I don't know what to call them. And the semicolon or the colon, which lets you know that the line is finished, and whatever is indented underneath is within the function. Okay, so we know that from automation, we know that from the for loops and the while loops, we know that from if, elif, and else statements. When you have a line in Python, you have the line declaring something, and when you have the colon, whatever is indented and below it is going to be a part of that block of code, right? So that's instantiating a new block of code. So we're defining a function name, and in this case, our function's name is function name. We add the parentheses, that's required, and the colon. So all those things are required to make a function, right? So the structure is very simple. We're defining a function with the correct syntax, and then everything underneath and indented is going to be a part of it. So all that this function has is a print statement inside of it saying inside a function, okay? So if we go to calling, we can come down here and we see after the declaration of the function and the actual, definition of the function, right? So defining the function, everything that's in the function, whatever comes after that it's below, but it's not indented, that's back into the regular program, okay? So the way that we call this, how do we run this function, right? The way that we run the function is by calling the function name, right? Just like you want to use a variable, you put the variable name out there. Same thing with a function. You write the name of the function. You have to add those parentheses. That's to tell the computer to call the function. So what we're doing is we're saying, if we look at this, we're doing this print statement, and then we go down, and then we're defining a function, and the Python interpreter, the computer, is saying, okay, well, we have this function, but we're not using it yet. So we keep going, and then right after the definition of the function, we're calling the function, so the function is going to run. All the code inside of this function is going to run, okay? And then once it's finished, the program comes back to, right here or, this next line and runs the next line of code, okay? So in terms of scope, I actually want to go to PyCharm and actually show you how this runs. So give me just a second. Okay, so we're inside of PyCharm and we have the same exact code that was written in that slide you just saw. So we have, let's just pretend that this is line 1, okay? So don't worry about what's above it because we got a bunch of examples on this one file. Let's imagine this is line 1. So line 1, we're gonna have a print statement. It's gonna print out outside a function. Then we're gonna define this function. Then we're gonna call the function. And then we're going to print out another line that says outside the function. So what I'm thinking is some people may think, because first off, I want to run this so you can see a function running, but also we're talking about scope here. So we're talking about I don't know how I would define scope, but it's like what's important right now. Okay, I want to put it in layman's term. I want to say, okay, well, what is known and what is important to the computer right now? You might think that it would go this, then this, then this, right? Because up until this very moment, in all of my videos, Python has been procedural. It's been one line after another, after another, after another, until we get to the bottom of the program, and then the program finishes. So we go from top to bottom, and we execute every line. But now we're focused on the scope of what's actually being considered by the computer. What we can see is we've got the print statement, the function definition, calling the function, and then another print statement. So what we're going to see is it's going to hit this print statement, go to this function call, come back inside, or it's going to go inside a function, and then it's going to go outside, okay? So I'm just going to run it. And just like I said, so we start with outside the function, inside the function, and that's because we're calling it here. And then again, outside the function. And I just realized that might not help understand what's going on here. So what should I do? I should add another. I'm just going to add another one of these print statements. So you can see we are outside the function. We skip over this because we're not calling the function yet. We're not calling, function my name. We're calling outside a function. Then we're calling the function. Then we're printing it out again. I hope that makes sense that the computer reads this and it skips over it. It recognizes that there is a function, but it doesn't run the function until it's called on by the programmer, okay? Great. Now that you somewhat understand what a function is and you have seen a function, you've seen it on the slides, you've seen the syntax, and we've seen it run, let's talk about when do we make functions. I have a 3x rule, 3 times rule. My 3 times rule is that if you ever write unique code 3 times in a single program, it should be a function, okay? So I always use this sandwich explanation. I don't know why, but I always say this sandwich thing. And basically, we're gonna see it in one of the examples for the automation versus functions. But if you have a program that makes sandwiches for people, let's just say it's printing out the the steps for making a sandwich or just the ingredients, bun, lettuce, meat, mayo, whatever is on your sandwich, and you have to do that 3 times. So let's say that's 5 lines of code. That's bun, lettuce, meat, cheese, bun. Okay, that's 5 print statements. When you're writing your program, if you have to make 3 sandwiches, you have to write those 5 lines of code. That should be in a function, and you should only have to write it 1 time. So that's the beauty of the function. That's the whole point right there, is that your function allows you to write unique, powerful code once, and you don't have to write it again. The cool thing is that I can write a function that just makes 1 sandwich, and I can call it 1,000,000 times. So let's actually just go through it. So I know that functions versus automation. I'm going to actually go back to this. Let's just go into the function versus automation. Got a little excited there. Let's just so excited about teaching about functions. So this is what it would look like I just mentioned, without the function. So this is a program that makes a sandwich. I've got print making sandwich, print bun, print mayo, lettuce, or lunch meat, lettuce, tomato, bun. So that's actually 2, 4, 6, 7 lines of code that is going to need to be written multiple times. Actually, this might be, I should have another example here that has it written multiple times. I will actually write that right now. Okay, so look at this example. Let me comment this out right here. So this one goes a little bit more to the why it's awesome to write functions. Let's say that my program just covers what I do in a day. Okay, so it does that by printing statements out. Print, wake up, I make a sandwich. Okay, so that I'm gonna wake up, I'm gonna make a sandwich. Then I go to school and I make a sandwich. So I have to write that code again. Let's say I wanted 2 sandwiches, so I have to write that code a 3rd time. Then I go and I hang out with friends and I want another sandwich and I have to write that code again. Okay, that's really time consuming. Let's see, this was 7 lines, right? So 1, 2, 3, 4. So I had to write 7 lines 4 times, and I'm really lazy, so that's way too much. It's really not efficient is what it is. So functions are really about being efficient. So you're going to see what this looks like if I put it into a function. So I'm actually going to skip over the automation part really quick, and we'll cover that. I think I kind of jumped the gun on the automation versus functions when I should have explained what I'm explaining currently. So you just saw that if I wanted to have a program that had my whole entire day written out and I ate a lot of sandwiches, I would have to write those 7 lines of code over and over and over and over again. This is what this program would look like if I had a function that made sandwiches. So this is line 1, and line 1 defines a function called SammyTime that has this. We'll leave it here. So What it does is it does a for loop a specific number of times. It's always going to be one. Okay, so it's always going to do it one time. And we're going to make a sandwich. So let's just imagine that when I call this function, when I call this function, when I call Sammy time, it's going to print out one sandwich, okay? So let's take a look. Here's essentially that same thing, a day in the life, washing clothes, seeing a movie, make a sandwich, go on a date, make a sandwich. Obviously the date didn't go so well, so we go to sleep, make a sandwich. While you're asleep, I don't know what it is, but back to sleep, make a sandwich and then go back to sleep. See how I didn't have to write those 7 lines of code over and over and over again? So we went from, this was a whole day, right? From here to here with 1, 2, 3, 4 sandwiches. And then when you write a function, I can add a 4th sandwich in here. This is what essentially the same thing looks like. We're covering my whole entire day, and we're making 4 sandwiches throughout the day, but I didn't have to write those 7 lines of code over and over again. I know that we're talking about writing a couple print statements here, but imagine that this is some sort of, maybe a little bit more complex of an algorithm compared to just printing out, words or text to a screen. Imagine if it was, crunching numbers, or it was a math algorithm, or, I don't know, evaluating a couple states of different variables, and, you have to do it over and over and over again. It's way easier to put into a function. Not only easier to put it in a function, but you're not going to mess up. If you write the function correctly once and you test it properly and you know that it works, then you know that you can just keep calling that function, right? So you write it correctly one time, and then you don't have to worry about it ever again. So that goes to kind of like if you were doing a program that did some math calculations, and maybe it was specific. I don't know what it is, but you write a program that, does a math calculation. And if you have to write it 100 times into a program by hand, every single time you have to write that algorithm, that math computation out in Python code, there's a large potential that you could mess it up somewhere. And you might not even know that you messed it up, but you messed it up somewhere, and then the number's not right. And now all of a sudden we're going to nuclear war because, no, I'm just kidding. But if you wrote it in a function one time, then you could call it 100 times, and for sure every time you call this function, then it's going to run properly, and you're going to get the correct output, which is really cool. That is why you write a function. So I write a function when I have to do something more than 3 times. Like, so if I wrote a program and I had to make 2 sandwiches, and I was documenting my whole day and I make 2 sandwiches, maybe I would write those sandwiches out. Maybe I wouldn't put it in a function. But let's say that every day I make 20 sandwiches, I'm probably going to write a function for those sandwiches, right? So the ability to write code once is probably the biggest thing. The security that your code is going to run the same every time, right? Little bundled algorithm that you can just call and call and call and call, and it's always going to be the same. That's a plus too. And I think the next thing, let's now go and talk about the automation versus the function. So when do you use automation? When do you use a function? Because, something like if I have to make, it's really easy answer, honestly, because think about this. Like if I have to make sandwiches, let's stick on this sandwich thing because this is for some reason the example that I've chosen. We're going to get into some real functions here in a little bit. This is just so that I can explain functions without having to talk about some other stuff. I have other examples, don't worry. So I'm going to comment this out real quick. So this is what it would look like. Let's say that I needed to make a certain number of sandwiches back to back to back to back. Let's say I needed to make 20 sandwiches, or I needed to make 6 sandwiches, or whatever it was. But in a single blocking, I needed to make a number of sandwiches. At that point, I would think about, and then you wouldn't have to make any more sandwiches anywhere else in the program. If it was just that one time, like when your program got to the spot and it needed to make 20 sandwiches, and then it would move on and start doing other stuff, I wouldn't make a function. I would just put that into some form of automation. You can see that I have like a user-guided input automation, or you could put it into a for loop, right? You could say for I in range 20, print all the sandwich out, right? And it would print you out 20 sandwiches, and then your program would move on, right? So that's what we have here. So I'm actually going to, run that. I just realized I didn't run any of the last code for the last couple examples, but it's okay. If you understand the print statements, then there's really not a reason to, for me to run it. But here, let's take a look at it. So I've got this program running. I haven't tested it, so I hope that it works. And user Sammy equals input. Would you like a sandwich, Y or N, for yes or no? And then it just says while user Sammy equals Y, run, print a sandwich, and then ask the user again if they'd like to make a sandwich. So let's say yes. Okay, so we printed out 1 sandwich, 2 sandwich, 3 sandwich, 4 sandwich, 5 sandwich. Okay, so we printed out a couple sandwiches, right? And then the program was done. So after I was done making those sandwiches, it just went all done eating, and the program went off and did its merry thing. But if we go back to the example that I was just working with, the function, this would be hard. This would be hard to put inside of a loop, because the activities in between making a sandwich and doing something it varies, right? It could be 4 things. Like I could do something else, and I could let's say did I already say go for a walk? So let's say go for a walk. So maybe this is on Tuesday, and I read a book. Man, I make myself sound like I'm really cool. Like I go to the movies, I go for walks, I go on dates, I read books. I do the walking and the book stuff, but no dates. Promise my wife. So when you look at this, every day could be different. So that could be Monday, and then Tuesday. Let's say I had 2 sandwiches before I went to sleep, and then I had another sandwich. Let's say I just went crazy on the sandwiches that day, and I even started my day off with a sandwich. So this would be really hard to put into some automation. So a function is a great opportunity for that. So I can say, okay, well, I don't know how to explain that any further. Honestly, I'm just saying I can make 20 sandwiches in one go and then be done with it. Then I would put it in automation, or I can run this code and put it into a function, and that way it's a little bit more robust, and I can do whatever I want, right? I can make a sandwich and add other activities, and it could be multiple activities or one activity, and then I can make 20 sandwiches or 1 sandwich, or I could even put this in a loop, and I could say for I, and I can make some Sammys, right? And, if I want to run this, I can. It's going to be a lot of text, and we're not really going to be able to see it, but, here we are at the top. So, make a sandwich, washing clothes, seeing a movie, go for a walk, make a sandwich, make a sandwich, make a sandwich, make a sandwich. Okay, so those are the 20 sandwiches we were supposed to be making, right? Functions are just really robust, and they allow you to kind of use that code but the functions allow you to use that code whenever you want, which is awesome. So another thing that actually we should go back to the slide so I can cover the points that I've outlined. Oh, look, I had a purpose for talking about functions versus automation. So I even made a Venn diagram. On the left side, you've got functions. On the right side, you got automation. And in the middle, you've got what's similar. Okay, so functions can be called anywhere in a program. And that's kind of the concise version of what I was trying to say for the last 10 minutes. And on the automation side, automation only exists in local space. So like I was saying, is the for loop or the while loop only exists right there. You can't just then reuse that while loop somewhere else in the program. That's just not how it works. So a function is the best part of that. Now, what do they have what are they similar in? They both can be executed any number of times. So the automation can be executed an unlimited number of times, and so can the function. It's just about where they can be used. So the automation can only be used in one space, and then you have to go and rewrite that automation, while the function can be used anywhere at any time, okay? one thing that I wanted to mention, so let's black this out. So I did mention here, or not mention, but I wrote this. So we have a parameter, okay? We can actually input value into our function. When I have it set up like this, it basically means this parameter, if nothing is passed into it, this parameter equals 1. So for I in range 1, that's why we were only getting one sandwich every time I called Sammy time, because this is basically equal to 1, okay? Not basically, it is equal to 1. When I call Sammy without passing any specific number in there, it's going to print me out one sandwich, okay? So that's just the design choice that I made. And if I go here, I actually have an example of it. Oh, what did I do there? I did something. I collapsed it. There we go. So here is an example, and this time I'm actually passing value into the function. Okay, so I'm actually telling the program how many sandwiches to make. So if I hit run, you're going to see we're washing clothes, we're seeing a movie, then we're printing 3 sandwiches, 1, 2, 3, and then go on a date, sleep, back to sleep. So it kind of took the same code here, and I can make 3 sandwiches just by passing 3 in there, because now this number, this just means if no number was specified, 1 is given. But since I passed 3 in here, you've got for I in range 3, and that's why we get 3 sandwiches, okay? So I can change this number to, let's do something obnoxious. Let's say 100 sandwiches. So now it's going to say for I in range 100, make a sandwich, you know, and then it's going to go ahead and make 100 sandwiches. And if I hit run, you can see that's a whole lot of bread. There we go. Okay, that is really, I'm like, oh, we'll just scroll up a second. Scrolling for 3 days. Okay, so that's a parameter. I have a couple other examples of functions with parameters that we're going to see in just a second. So I feel like the last example where I had the this right here, the predefined parameter, is not a good way to introduce the concepts of parameters. Not that the concepts of parameters are too difficult to understand. I hope that you're able, you know, if you can program, you've gotten this far, you should be able to understand, like, oh, I pass in stuff, right? Like print is a function. And the input, this stuff right here, is the parameter passed into the print function. So shouldn't be too hard to wrap your head around, but I wanted to make a little example to explain. So I've got this function called dumb function because it really is kind of stupid. And all it does is it prints the number passed in, right? So inputted blank, which is whatever is passed in. There's no equals 0 or whatever. We'll explain that. So I'm going to call it 3 times, and I'm going to pass 4, 10, and 1,000 in. So it's going to say inputted 4, inputted 10, inputted 1,000. Did it run? Yeah, it did run. So inputted 4, inputted 10, inputted 1,000, right? Not too hard. Whatever I pass in there, if I pass 22, then it's going to say inputted 22, inputted 10, inputted 1,000. You can add as many as you want. So I could do Y, and they could be named anything. Let's name it Pi, Bob, just to show that we can name them literally anything. And the cool thing about parameters is that when you input parameters, they allow you to not only use your function, but they allow you to work on, you know, value outside of the program, or take value from the outside of the program to influence the output of the function. Whether, you know, I don't know where those inputted values come from, whether they're user generated or they're programmed. Maybe they're generated from another output of another function, right? And they sent them into the current function that we're talking about. Maybe they come from sensors from a robot or something. It doesn't matter. Parameters help extend your function to work better, or maybe have a more granular output. So we can have as many as we want. Cool thing is, let's say I just added three parameters. Now I got to add 3 different values. Actually, let's do 222, 22, and then 2. I don't know why. And then this one will do. This one will be 100. Actually, this one will be that. Yeah. Okay. And okay. Stupid, but we're doing it. So just to show you, you can have as many parameters as you want. Now, what you need to realize is 222 is X. So when you're kind of debugging or looking into functions, dumb function, you're like, okay, well, we're passing 3 values in. You go to the definition of the function and you say, okay, well, 3 parameters are needed. And then if you want to see, you can say, okay, well, on the first line inside the function, that first parameter X is being used, and then pi, the second parameter, is being used. And I know that that's 22 because I'm looking first parameter, second parameter, first parameter, second parameter, parameter, blah, blah, blah. So let's just run this, and you're going to see it's going to say inputted the first number, then it's just going to output the second 2 numbers. Just as I prophesized, inputted first number, and then just simply output the second 2 numbers. Nothing special. Cool. So that's parameters. And then on top of that, let's get rid of the other 2 parameters. And just to kind of explain, so now we have X. So if right now, and I'm going to get rid of the multiple function calls so we can focus here. Focus up. My function requires a parameter. I have to give it a value or else it's going to give me an error. I don't know if it's going to pull up a error here, but if I run it, it's going to give me an error because it's going to say dumb function required 1 parameter, none were given. Exactly. So type error, dumb function missing 1 required positional argument, X. That's what it's called inside the function. Okay, so we have to give it a value. Now Python's really cool because in like C++ or something, you have to explain the data type. But in Python, I mean, it could be shit. It could be L. Inputted L or whatever. But obviously make sure that it's the right, because you don't want to do something that's wrong. So sometimes they'll have like comments. I don't know. I'm not a professional here, but I know that they have stuff like this, and they'll say, okay, parameter, and I'll say parameter X is an int. That in PyCharm, by the way, what I just did. So you can drop in here, and if you do 3 and I hit enter, this is kind of like a little statement. I'll be like, this function, if I can spell it, is my first function. And we'll just leave it at that. And then it will be like, okay, parameter X, and we'll say int stands for okay, now that we're getting, so now we're actually, doing something, kind of going off script here. But let's say, let's change this, and we'll say my age is. So now our function actually has something. So let's actually change it to a proper name, because that's important, right? You want to name your function, just like naming your variables and things like that. You want to give them important names that, go to the actual function. So define, let's call show age. So this function just got changed to the name show age. And we can actually change this to be age. So I'm just sitting here being dumb. But let's say my age is 25 because I'm 25. Okay. That's okay. So my age is 25. So whatever I put in here, my parameter 25 is a parameter I've passed into age, and I knew that I needed an integer for the function to work properly. I mean, I could put anything I want, and I could run it, and it would work. But at some point, that might not work for what the actual function is supposed to do. So that's why you have to worry about that. But, my age is 4. So my age is 4, and it's going to output that. I hope this is making sense. I just thought that would be a good thing to talk about really quick before we move on to a different example, which, you know what? Let's just go to it now. Okay, so return is the ability, all you've seen so far is functions that uh, print as their output. So I know that that might be a little confusing now that I'm thinking about it. That might be a little, wow, now that I've done 7 examples of it, I realize that that might have not have been something to lead with. But our function hasn't been outputting anything back to the caller of the function. Okay, so whenever you call the function, that's who calls the right. Our functions so far have simply been printing to the console rather than outputting any information. When you want to send information based on the procedures within the function back to the caller, you want to use a return statement, which I don't know why it's, okay, silly me. I had literally POW, which is already a built-in function in Python, which does the same exact thing of which we're doing currently, but we're going to rebuild it. So there's a built-in method called POW, which will extend a number to the power of, power of 2, power of 3, whatever the power is. We're going to rewrite it ourselves, and we're going to use the return value so that the caller can do whatever they want with the finished product of the function. So this function, let's take a look. We're defining def, we're defining power, a function called power, which takes 2 variables, x and y. Let's also make sure that x is always going to be 1 and y is always going to be 1 just in case. Then we are going to create a new variable called z, which we don't have to do. We could just return it. But z equals x to the power of whatever that value is, right? So x is going to be the base, y is going to be the exponent. So once that operation is complete, we're going to return z, whatever the output of that operation is. We're going to return that value, return z, to whoever called it. So in this case, let's just print. I'm just going to print this out first before I realize that we have this all in a bunch of different stuff. So I'm just going to. Okay, so what I'm going to do is I'm just going to output the 4 squared, right? 4 to the power of 2 is what we're doing here. 6. That's not correct. Okay, I just realized. Sorry, I'm telling you, it's been a while since I've been doing these videos, and also I've been working on some different stuff where that is, that's the exponent sign, is that caret, right? So, that would be the exponent, but that's not it in Python. In Python, the exponent is the double multiplication sign. So we should get the correct, yeah, there we go. So 16. Oh man, I feel stupid sometimes, but that's okay. So z is going to get the value of x to the power of y, and we're going to return that to here. I know that that's stupid. I know that we could just do 4 to the power of 2, but just bear with me. I'm just trying to show that we can send data back to the caller of the function. So now that you can kind of see that, look at this. So we've got this statement, the square root of blank is blank, and that's going to be 4 to the second power, 4 squared. And then we have another statement that just says blank times blank equals blank. So that would be 5, right? So we have 5. These are just for formatting issues. But right here, we're calling the power function that we made, and we're saying 5 to the power of 3. So we should get 16. We should say the square root of 4 is 16. Then 5 times 5 times 5 is 125. Hopefully I got that math correct. Somewhat. I'm not even sure if I got it correct because I don't know if my Python's correct at the moment. I'm kind of nervous. No, I know that we're good. So that's a return statement. That's what happens with a return statement. What you can return anything you want. I mean, I can return. I know this is going to mess our program up. Here I'm just going to say power for 2 again, but the return value is just going to be x. Okay, let's just say that the return value is X. So nothing's going to happen here. I can return anything I want back. Oh, actually, hold on. I need to print this out because nothing's going to happen because I'm doing nothing. No, now for, our X parameter, for in this case, X is going to print out, or it's going to be returned back to this print statement. So really, this is print the return of the power function, which is 4, right? I can do, we could get wild here. This is just me being dumb, but you can, just say hi or something. So we're printing the return of whatever happens. The program doesn't care what happens inside the power function. It just says whatever is returned in that power function, send it back to this exact location, and then continue the operation that was in progress. So print starts, realizes that this is a function call, goes into power, does whatever it wants, whatever it's supposed to do inside of power, and then gets that return value and plops it right there. So in this case, it's high. We've kind of destroyed this function. I don't like that. But again, we're doing 4 to the power of 2. We can do anything we want. This is gonna be a big number. It is a big number. And again, we're just using the return value. We can do another one too. So I've created this other function real quick. Define is red, and we pass it a color in, and then we have this this Boolean variable, true false, and all we're doing is we're checking if the color passed in is equal to the value of red. If it is, we change it to true, and no matter if it's true or false, we're returning that true or false variable, which is really cool because we can now use that inside of an if statement, and I can say my color equals blue if is red my color, print yee, your favorite color is red, else print no, you hate red. Let's see what it outputs. No, you hate red because the return value of is red is false. If I change this to red, possibly, we might get a different output. Yee, your favorite color is red. So all I'm showing here is we are using the return value, which is a Boolean, true or false, from is red in this if statement. And we're using it as our check for, whether or not the if statement should execute or not. Okay, so last example, I wanted to show, I use functions a lot for little input validations. If I'm making like a command line prompt, like I have this, at the new year, I started a challenge, like a challenge where I have to work out and I've got to, I have to read and I have to do all these different things, right? And it's just a command line, console application. So I just run it, and then for my terminal, I can input what I've done for that day. It's just a way to log what I do. But there's a lot of simple inputs, that I'm typing in and then hitting enter. The program prompts me, hey, what day is it? And I put in the day. Actually, it grabs the day. It makes the day for me, but it says, hey, what did you do today? And I write it down, and then I input it. And based on that, the program continues, and then at the end, it asks me what I wanted. So there's a lot of user input, and a lot of that stuff, in my opinion, needs to be validated to be the right type of input. So I like to write these little functions, these little user input functions, where the function can actually take the prompt that the user is going to see and then store the different acceptable inputs and check to make sure that the user is inputting, and it keeps running the same function over and over again until it does the right thing. Right, that's what I was trying to say. Let's just run it and see what. So this is the use case number 1. So let's just run. I'm gonna run through the function. Define get input, and we got 2 parameters: prompt and values. User input equals nothing, something stupid. So I can start this off. While user input not in values, so right now currently the user input is not in the list that I'm going to pass it. You're going to see that in a second. We're going to try to get the user input based on the prompt that we were passed. So it's going to be some some phrase or sentence that the user will see that will prompt them to input correct user input. And once it is a part of the values list, then we break out of it and we just return the user input to be processed later on. So this is the function itself, and down here is, outside of the program where the function is actually going to be used. So user in equals get input, which is this function, and prompt is, would you like to keep playing? So let's say this is a game or something. Would you like to keep playing? And the acceptable inputs would be Y, capital Y, lowercase, capital N, and N. So when we run this, the prompt that the user is going to be prompted with would be, would you like to keep playing? And it's going to keep prompting them until the correct input was received. Okay. So if user in equals Y or user in equals N, I mean, I could even do this dot upper. I could kind of drop that off. So now we're forcing whatever the input is to be uppercase, because we know it's either N or Y or N. So we'll just make it an uppercase one. So I say if user N equals Y, start new game, right? Because we said, yes, we would like to keep playing. Else, all I have to do is say else, because I know that it's either Y or N. So if it's not Y, it's N. Else, say goodbye. So let's run this. Open this up. Would you like to keep playing? Y, starting new game, processing. Okay, so that's it. It just, imagine that was at the end of a game, like when you completed a match or something. It says, would you like to keep playing? You input yes, and it keeps going. It only happens once down here. Notice it only happened once because it validated on the first try. So let's try it again and not validate it. Let's say I put in something wrong, and I'll say L, would you like to keep playing? No. Nope. Maybe. So it's going to keep prompting me until it's one of the correct possible values, okay? I don't know. This is just something that I do on my own. I think it's a really cool little function, especially because when I have programs that do a lot of user input, I can just write this one function once, and then anytime I need user input, I can just pass a string and the values that I'm looking for. So actually my string should have been like this. Should have added a Y or N because the user really didn't know what to do. So now when I run it, you can see it has Y or N. Should be Y/N. There we go. So I can do something like this. And then if I do, pi or Y, fly, it's not going to work until I put N. So if I put N, that's in the accepted parameters that I passed in, the values. So while user input not in values, keep going. Notice something cool is I passed an entire list to the function. Now, people who are worried about efficiency and things like that might say that that's not the best thing to do. But screw you. I don't care. Awesome. So that, this is kind of a function that you're definitely going to want to pause the video for. So I'll kind of go like that. So if you want to pause the video and take a look at this and write this code down for yourself, again, if you're sitting here and watching this video and you haven't written a single line of code, you're probably not going to understand a whole lot, but you need to be sitting there and writing the examples that I make to get a better understanding of what I'm doing. So this is definitely an example of something that I would say, test and write on your own and give it a test. So this was just one use case for it. So imagine that we're, playing a game and we wanted to know if the user wanted to keep playing. Here is another use case. I don't remember what it's for. Okay, what would you like to order? Pie, cake, or toast? PCT. Let's not worry about all that stuff. So this is literally the same, the same kind of thing as this. We're going to get the user input by calling this function. We're going to pass a prompt, and we're going to pass a list of acceptable values. And this should probably also be, if I wanted to be serious about what I'm doing, I know that that's not, it's kind of annoying, but I would add those just in case the user, actually, you know what? Because we're telling the user exactly what to input. So if they can't input that, then that's their fault. But it's the same thing. So we're going to keep asking, right? Because we're calling this function. So we're doing the same exact thing as here. This is a really cool example of, you know, a function that does the same mechanics, but in different use cases. So we're going to call get input. We're going to pass the prompt and the acceptable values, and we're going to execute this code until we have a proper response, which is within the values provided. And then we return that, and then we do something with that. And so now that I know that the user input is either P, C, or T, I can say if the user input was P, we can say pie time. If the user input was C, we can say let them eat cake. And if it's not P or C, we know that it's T, and we say toast it is. So let's go ahead and give this a run real quick. What would you like to order? Pie, cake, or toast? And I'm going to say I would like pie, please. Pie time. Rock on. Again, take a moment, write these down, give it a shot so you can understand. I have these commented out because they're different use cases, so I would want to test one at a time. So this is use case 1, all this right here, and then use case 2. Give that a try. Both of them are using the get input function. Both require 2 values. And that's about it for the functions. A little bit of bonus information for you that I wrote down, just kind of thinking about functions, making this video. Functions should be short and concise. Functions are modular and should be flexible enough to handle modifications. Too big and they become hard to modify. So I don't know if any of you guys have ever had this problem, but when your program gets a little too big and it's not organized properly, and you go and, you know, let's say that there's something fundamentally wrong with your program and you're like, shit, I got to go back and rewrite something, you know, and one little change causes, you know, a chain reaction of things that need to be changed down the line. Functions are great for that. So if you start putting everything in functions and you keep them nice and small, you know, functions should have one defined operation that they do. Validating user input, you know, multiplying a number to a specific power, whatever it is, some of these examples that we showed, the function should do one thing and either return the value, modify the values, or, you know, do whatever, right? So keep them small, because if they get too big, you know, the problem with too big programs is that when you make a modification, it's hard to fix them. If you make your functions too big and then you need to fix your function, then, you know, they might be too big to fix, right? So this is something that I struggle with all the time. I'm interested to know if you guys struggle with this, if you, you know, if you guys have written programs, you know, somewhat on the larger scale by yourself, let me know. This is something that I'm always trying to do. You know, I follow my 3 times rule, and I try to put everything into functions and keep them small and concise. The more you can kind of comply with that, the more efficient you're going to be, and the better modifying your programs is going to be. You're going to really, really see an improvement in your ability to kind of iterate and test and modify and make new versions of your code. Also, functions help organize programs, kind of like what we were just talking about. Ever wonder where that code that modifies your list is? Well, it's probably in the function called list mod, right? If your program is really big, but everything is inside of functions, if you have a function that modifies a list, if for some reason the list operation isn't working, or, you know, the output from the list, or whatever you're trying to do with that list, let's say it's not, you know, modified correctly, and you're like, man, why is this not working? Well, if you have a function that only is there to modify that list, the first place you can go is to the list mod function that you wrote, right? So keeping organized is a really great way to identify problems and going forward and saying, okay, well, this is where I'm definitely going to start, because it's either when the list is being passed into the function, when the list is inside the function, or when the list is being returned by the function. You know, whatever those operations are, I'm going to go to list mod function and look at that first and go from there. And the last thing, functions are great for testing. So again, these are kind of compounding thoughts that I had, right? They kind of build off of one another. There is a concept called test-driven development where you identify not only what the code should do, but what it should be able to handle. Functions are an easy way to develop in this fashion, I have found. I will be making a video on this topic soon. So I've got, some energy. Hopefully I can make some more videos here soon. And one of them is test-driven development. I think that's a really cool way to make a program. Basically, you just identify what you're trying to do, and then you try to identify all the cases in which something would fail or something was wrong or a user inputted wrong, like kind of like that user validation function that I wrote. That is a great example of like test-driven development. Rather than thinking about just getting the user input, you think with a mindset of like, okay, well, users are stupid and they're going to input something wrong. So how do I create code that can handle a user that inputs code wrong, right? So I write a function that keeps asking the user the same question until they input correctly. Maybe a little annoying for the user if they keep inputting the wrong information, but at least I know I'm building a program that's going to work, right? So that's really cool. So I'm really excited to make a video on that. Hopefully, I continue with making the videos on a more regular basis. I really want to, but just with time and everything in life, and it goes by so fast. So thank you so much for watching. If you've made it this far into the video, I really appreciate it. If you haven't made it this far into the video, then screw you. I really don't like you if you haven't made it this far, but no, I'm just kidding. Seriously, if you've made it this far in the video, thank you so much. My last couple of videos have really gained a lot of traction, and people are interacting with the videos, which is really cool. And I love your feedback from everybody. I hope the quality of these videos are getting better, and the information that I'm giving out is good. So I would love to hear your feedback. Anything you guys want to see, let me know in the comments. Please give me a like and subscribe so I know that what I'm doing is helping everybody. Great. So thank you so much, and I will see you next video.